Hello everyone. I want to talk a little bit about the presentations that we'll be doing in lab towards the end of the semester. First of all, I want to talk about why we're doing this. So I know sometimes doing a presentation is not the favorite thing for many students, but we're actually doing this for your benefit. This is not something that I've done before when teaching this class. Traditionally, we covered a lot more material, and sometimes that is just too much for some people. So we've trimmed down some of the material a little bit to focus on what are the real core chemistry concepts. And so we're focusing on those concepts in a lot greater detail and leaving out, just completely leaving out, other than maybe just briefly touching on other ideas that are maybe not essential, but for some of you may be very, very important. So I want to make sure we leave a place for addressing those topics and letting you choose which of those topics you find interesting. And I felt like the best way to do that was with a kind of a presentation. So the idea here is that you'll pick a topic that you find interesting for your area of interest, and then with other people that also find that topic interesting, give a presentation. So you'll have a lot more depth on what matters to you, and then just kind of a service level listening to what other people say about things that maybe are not as important to you. These are the various topics that could be options for you, and we'll go through each of these separately on a separate slide. But in general, I just wanted to say, as we're kind of looking at these initially, most of you are probably not chemistry majors, so you're taking this course because it relates to another thing that you're more interested in. So the idea here is we're taking, you know, the chemistry topics that are in your textbook and connecting them to things that you have a greater interest in. So you can kind of, I guess, in a way, fine tune what you are learning here to what you will be interested in more in the future. So I'll go through these one at a time and talk about why you might be interested in them. If it sounds exciting, then that might be the one for you. If not, then there will be others. Okay, the first one is the half reaction method. This was in section 4.2 of your textbook, which was a long section, and it's kind of towards the end of that. We covered other parts of that section, so it's only the part on balancing redox reactions via the half reaction method. This is something we actually revisit in the second semester. So if you are planning to take the second semester of general chemistry, you could kind of start the process of learning this now, so it will be easier when you get to it later. This is also about an electrical process, so if that's something that is of interest to you, then that would be another reason to look at this. Also, if you really like balancing equations, this is taking that to the next level. So a couple of reasons why you might want to do this. If you are doing this presentation, you will discuss the process for balancing a redox reaction in this way. And then as part of your presentation, I will give you an example that I would like you to balance as you do that. The next option is the development of quantum theory. This is section 6.3. Some of this were covered and some of it was not. So the part that was not covered of section 6.3 is what you'll be focusing on here. So some reasons why you might be very interested in this. You like physics, you're really interested in that. You are interested in Heisenberg. I'll just let you interpret that however you want. And then you are interested in things that are just weird. I will not, it looks like the interested there is spelled a little bit differently. It has a weird spelling. I'll pretend I did that on purpose. But this is just weird stuff. So if you like weird things, this might be something for you. So these are the things that I would expect you to cover in this kind of a presentation. Wave particle duality and the experiments that led to this conclusion, some of the implications of the Heisenberg uncertainty principle, and the relationships between the first three quantum numbers. And then also determine the quantum numbers of an example that I will be providing for you. The next option is bond strengths. This will be section 7.5. Pretty much all of it, we didn't really cover that at all. Some reasons why you might want to do this. You really like thermochemistry calculations. Maybe you're going into engineering, or maybe you're interested in inorganic chemistry. So these are kind of some reasons why you would want to do this option. Things that should be covered in this presentation. You can do you'll do an example of estimating the heat of formation for an example that I will be providing for you. You'll discuss lattice energy and how that relates to trends in ionic bond strength, and then describe the Born-Haber cycle, or I'm sorry, Born-Haber process. The next one, molecular orbital theory. This is section 8.4. We did briefly touch on the kind of some of the reasons for molecular orbital theory. We didn't talk about the molecular orbital energy diagram, so that's what you'll be focusing on. So some reasons you might want to do this one. You like chemical bonding theories. You like electron configurations. Or you are planning to take organic chemistry. This is something that does become important in organic chemistry. So some things that you should be covering in this presentation. The basics of molecular orbital energy diagrams. What is a bond order? How do you calculate that? You'll solve an example of a molecular orbital energy diagram that I'll be providing for you, and then discuss prediction of magnetic properties for the energy diagram that was provided for you. The next one, effusion and diffusion. This is section 9.4 of the text. Some reasons why you might want to do this. You like learning about gas properties. You want to know how to separate gases from each other. You are interested in either biology or chemical engineering. Things that you should be covering in this presentation. You want to define mean free path, diffusion, and effusion. You want to explain Graham's law of effusion, and then do a calculation related to ratios of effusion that I will provide for you. Just to note, this is a topic I've hardly ever covered in much detail in my general chemistry courses, but it is related to a topic I did research on when I was in graduate school. 9.6, non-ideal gas behavior. So some reasons why you might want to do your presentation on this. You like learning about gas properties. You want to know about compressed gases. You are planning to study physical chemistry or engineering. So some things that should be covered in this presentation. You want to explain the compressibility factor and what leads to non-ideal behavior. An explanation of the components of the van der Waals equation that account for non-ideal behavior. And then perform calculations and compare the results of an ideal and non-ideal gas provided by the professor. The next one is crystal lattice structures. The section of the textbook is 10.6, unit cells of metals and X-ray crystallography. Some reasons why you might want to do this. You like visualizing three-dimensional shapes. You want to know how X-rays work, or you are planning to study material science or solid-state physics. Just to note here, I have had previous students who had a prerequisite of Chemistry 1A specifically because of a material science course they would be taking later. I think this is mainly for engineering students. So if in your plan of courses to take, if one of those is a material science course, I would highly recommend doing this because this is probably why you're taking this course. So things that should be covered in this presentation: discuss the 3 cubic unit cell types, a calculation related to unit cells that I will be providing for you, and a brief description of X-rays and the Bragg equation. Also of note that in the same graduate school project that I discussed earlier, I did make use of the Bragg equation and X-ray diffraction as well. Colloids is the next one. This is section 11.5 of your textbooks. So some reasons you might want to do this. You want to know more about mud, jello, soap, or milk. These are examples of things that fall into this category. You want to know more about categorizing matter. You are planning to study biology or environmental science. So if you're doing this presentation, you should discuss the following: definitions of colloids, suspensions, emulsions, and gels, explain the Tyndall effect, and explain how soap works. So how these presentations will work: you will select a topic that you would like to present on. If you do not select a topic, you will be assigned a topic, and so please select something you like. So please pick something here. You'll be on a team with other people who also selected this topic, probably teams of 2 to 3 people. If you are the only person that finds something very interesting, I will let you do a presentation all by yourself if you want to. But if there's one topic that most of the class wants to do their presentation on, we'll either make some people do their second choice or maybe split that up into several teams that have a little bit of a different assignment there. We don't necessarily have to cover all of these topics, so if there's a topic that is never going to matter to anybody, that's fine if it doesn't get presented on. But we also don't want to have like a giant mega team where nobody really does the work except for maybe 1 or 2 people. So if we keep it to maybe 3 people at the most per team, that's the best way to do it. So hopefully this works out and we kind of get an even distribution. But if not, we'll kind of figure out our way out around that. So again, a lot of this will be kind of figuring out together. So we'll decide together on some of the ways we want this to work in terms of the details. I'm guessing these will probably take between 10 and 20 minutes. I don't want to be too much of a stickler on the time, but there's going to be kind of a bit of information, so I don't want to slow you down too much or kind of constrict you too much on the time. At the same time, everyone needs to present, so we need to have enough time in our lab time that can happen. And then we might have some options, and this is, again, a good big place where I want to get feedback from you. Will we do this in person or will we do it via Zoom? So there's some options there, and that's something we can discuss together. So be thinking about that, and how you feel about that will be one of the things we talk about. The presentation itself will be worth 30 points towards your lab grade. So basically equal to 3 one-day labs. So some things you need to be doing to get ready for this. So by the 28th of October, so that's the date of the 3rd exam, select a topic you would like to present on. So just of the ones that we just talked about, you don't have to do anything other than just pick one of them. The best thing I would recommend would be to do so before the exam. But if somehow you forgot and you get done early, then go to Canvas and do the survey. So just make sure you're doing the survey by the time we get back together to discuss this. And that again is on Canvas in the same place as very close to where you're finding this video. And then after the exam, how this will work, we'll come back together at 10:30. You'll be put into a group based on what you selected. And then within that group, you will have an initial discussion about your topic and start preparing for the presentation. So there will be some guidance to how this will work out. What I will say is if you're not, for whatever reason, able to be there, you might, we might have to think about how that will work. Let me just say it that way, because I don't know exactly what the options will be here. But I don't want your group to suffer if you're not there. So it might be that you will have to do it all by yourself, an individual presentation, or it might be that we'll have to get something where you're able to somehow collaborate with your group. One thing I will say is that if you are not there, you'll have less of a say in how this works out, because a big part of that initial discussion is how is this going to work out? So what would it look like for you to feel good about doing a presentation on your topic? So that is it. That's what you need to do to get ready. And just make sure you have all of this done by the 28th, and then we'll be, by all of this, I mean just picking a topic, and then if you have any ideas about things, how you feel about doing this presentation, there'll be time to talk about it on that at that point.